All right, so today's objective is that we know our inverse operations and can solve one-step equations. One-step equations should be a review. I know we did these last year. Some of you may have struggled with them. So when we jump back into equations, we're going to start with our one-step equations. So these notes are on Schoology. If you want to go ahead and print them and fill them all out as we go. Otherwise, you can go ahead and write the notes and the examples as we go. All right, so solving one-step equations. In order to solve an equation, we must isolate the variable. What that means is we need to get that variable by itself so we can figure out what it is. And then we want to keep each side of the equation balanced. So this is not going to be the greatest drawing, but if you look at the bottom left here, I'm going to draw my balance scale. If I have a scale, and I think these are still used in science class. This is a little bit old school. But, so if I have a scale and what I have on the left and the right are the same. Whoops. They are the same. If it'll let me write. It doesn't like when I write so close to the edge. All right. So if they're the same, it's going to be at the same level. If I add something, I'm trying to change the color. If I add something to this right side, what's going to happen? This is going to go down, and they will no longer be equal. So if I want them to stay the same, so I want them to stay at the same level, I have to add just as much as I added to the right, to the left, so they stay the same or stay equal at that same level. So in order to keep the equation balanced, what I do to one side, I have to do to both, so that this equal sign in the middle of your equation stays true. All right, so we can use our inverse operations to move terms from one side of the equation to the other. Inverse operations can be thought of as the opposite or the undoing operations. So in this chart here, they gave us our inverse operations. We have addition and subtraction. So addition, in order to get rid of addition, you'd use subtraction because that's its opposite. And in order to get rid of subtraction, you'd add because that's its opposite or inverse. Same thing with multiplication and division. If you have multiplication, in order to get rid of it, you would divide. And in order to get rid of division, you would multiply because those are each other's inverses. Awesome. Pause this if you're still writing. All right, so we are going to go ahead and we are going to work through some of these, and then I'm going to let you do some by yourself. So remember, when I have a number next to a variable like that, it implies multiplication. We learned that last year. We've seen it a couple times, I think, this year. But we definitely talked about it last year. So remember, if I have a number next to a variable, that means I am multiplying. And what did we just say was our inverse of multiplication? Division. So in order to get rid of times 4, I'm going to divide by 4. But remember, back to our scale. If I take away something on this left side, it's going to go up because it'll be lighter. If I want them to stay equal, I have to take away just as much on the right side. So if I'm going to divide on that left side, I also have to do it on my right side. Otherwise, this equal sign will not be true. So we know 4 divided by 4 is 1. So 1x is equal to 16. And I don't know why I wrote 6. 16 divided by 4. Because I divided by 4 on the left side, so I'm going to divide by 4 on the right side. And 16 divided by 4 simply leaves me with 4. And I can drop that 1 and write x is equal to 4. I'm going to see if I can select this. Well, how about we do this? We'll put that there. All right. All right. So moving on. Let's look at 4. I'm going to go down to 4. So I have a lot of kids, and I think you did this last year too. Some of you, at least. The ones that I had, some of you. You look at this and you freak out because for some reason there's this negative stigma with you children and fractions. You're going to leave my class and be a little bit less afraid of fractions, I promise. All right, so this is actually not a fraction. That line right there means that x is being divided by 5. So how do I get rid of division? What did we say our inverse of division was? multiplication. So in order to get rid of divide by 5, we're going to multiply by 5. And what I do to one side, I have to do to both so that the equal sign in the middle remains true. So 5 times x is 5x. 1 times 5 is 5. And we're going to leave 13 times 5 for a second just so I can show you. 5 over 5 is, 5 over 5 is 5 divided by 5. So 5 divided by 5 is 1. So we have 1x is equal to 13 times 5. Let's go ahead and multiply that out. I have 13 times 5. 3 times 5 is 15. 5 times 1 is 5 plus the 1 we carried is 6. So 1x is equal to 65. Or simply you can drop the 1 because we know it's assumed. X is equal to 65. Awesome. All right. And then I'm going to come over here, to 5 and subtract. So I have x minus 6 is 11. What did we say our inverse or our opposite of subtraction was? Addition. So in order to get rid of minus 6, I'm going to add 6. But like that balance scale, if I add 6 pounds to the left, I need to add 6 pounds to the right because I want them to stay equal and balanced and for my equal sign to remain true. So we're going to have x because minus 6 plus 6 cancels out to 0. And 11 plus 6 on our right side. Well, 11 plus 6 is 17. Awesome. So I want you to go ahead now and pause this. Pause this and work on 2, 3, and 6. And pause this when you're done working through these because I want you to attempt them and then follow along with me after attempting them to see how you're doing without my help on your own. Awesome. So by now you should have already had a chance to pause this. If you haven't, pause it now because now I'm going to go over this because you should have already paused this and worked through it. What did you say my inverse of addition was? Subtraction. So how do I get rid of plus 9? We use our opposite or our inverse. So we're going to subtract the 9 that we added. And again, what I do to one side, I have to do to both so that that equal sign remains true. So I'm going to subtract 9 on the left as well as the right. Plus 9 minus 9 cancels out to 0, so we're simply just left with x. And then 13 minus 9 is 4. Did you get that? If you didn't, do you see what you did wrong? If you don't see what you did wrong, these are awesome questions to bring to our guided practice. All right, so 3, I have x minus 8. What did we say our inverse of subtraction was? That's right, addition. So we get rid of minus 8 by adding 8. So on that left side, I'm going to add 8. But what I do to one side, I have to do to both so that my equal sign remains true. So add 8 on the left and 8 on the right. So I'm left with x on my left because minus 8 plus 8 cancels back out to 0. So all I have left is x because x plus 0 is just x. That's our identity property that we talked about. Anything plus 0 is going to remain the same. So we're left with x on the left. And because I added 8 on the left, I need to do it on the right. And 14 plus 8 is going to leave me with 22. Awesome, awesome. All right, so then I have 2 times x. What was my inverse of multiplication? Division. So to get rid of times 2, we're going to divide by 2. But what I do to the left side, I have to do to my right. So 2 divided by 2 is just 1. So I have 1x is equal to 88 divided by 2 is 44. We can drop that 1 and say x is equal to 44. Awesome. So I want to point out, I want to make sure that we remember how to do this. So when you are doing the actual work on this, not this, well, the guided notes, yes, because I want you to have examples of how to do it. But when we are doing the homework, the classwork, I want you to show your work. You might be able to tell me 4 times 4 is 16, or x, or was it 65? 65 divided by 5 is 13. You might be able to tell me 4 plus 9 is 13 off of your head, but I want to know that you know how to do this because we're going to start adding steps making this a little bit more complicated, so I want to make sure this is solidified in your brain before we get to harder problems. So when we're doing this, show your work, show me the steps, so that when we get further, you won't get lost. Awesome. So let's look at our one-step equations with some rational numbers. So they can include rational numbers. So now we're going to look at some integers, so the positive and negatives, as well as some fractions and decimals. So in this first one, I have 6 times x equals 16. What was my inverse of multiplication? Division. So we're going to divide this left side by 6 as well as this right side. Because what I do to one, I have to do to both. 6 divided by 6 is simply 1. So I have 1x is equal to 16 divided by 6. So we can either turn this into a fraction or a decimal. I'm going to make it a mixed number. So I know 16, if I divide it by 6, because 16 is on the top, so it goes in the house. Excuse me. 6 goes into 16 2 times, which is 12, with 4 left over. So we're going to say 2 with our 4 remainder over 6. So I can say x, and I went to write 2 over 4 over 6. X is equal to 2 over 4 and 4 over 6, which I can then additionally simplify to 2 2/3. Awesome. All right, so now I am going to jump to 9. So I have 2/3 times x. All right, so in order to get rid of multiplication, we use division. So to get rid of times 2/3, we're going to divide by 2/3. So if you had me last year, and I think I showed it to you guys this year, there was a video I showed my kids when we were doing division of fractions. He says in the video, he goes, to divide by a fraction, here's a tip. Keep, change, flip. So in order to divide 2/3 by 2/3, we're going to keep, change, flip. So that first fraction stays the same. You change the division to multiplication and you flip that second fraction. So what I see is that 2 times 3 is 6 and 3 times 2 is 6. We know this because they're the same but opposite. What I see is, and 6 over 6 is 1, so it cancels and it's just x. What I notice is that when I do that, all I have to do in order to divide by a fraction is multiply by the reciprocal. So to get rid of times a fraction, I can just multiply both sides by the fraction flipped or its reciprocal, because I'm going to cancel out 6 over 6x, which is just 1x. So I can go ahead and say that 6 over 6x is equal to 8 times 3/2. And then I can multiply them out. So remember, numerator times numerator, denominator times denominator. 8 times 3 is 24. 1 times 2 is 2. And if I simplify that, 24 over 2 is just 12. So x is equal to 12. Awesome. Let's see. I'm going to go ahead and I am going to jump down to 11. All right, so I have x minus 1.6 equals negative 8.2. Remember, what's my inverse of subtraction? That's right, addition. So in order to get rid of minus 1.6, I'm going to add 1.6. The one thing I want to point out, because it's one of the biggest issues I see with you kids, is when I have a decimal, and I haven't seen it so much this year, but I did teach some of you last year, and it was a big issue last year. When we are adding and subtracting decimals, line up your decimal. So I have negative 8.2 plus 1.6, but because I'm adding a positive and a negative, we're actually going to subtract and keep the bigger sign. And on the left, I just have x left because minus 1.6 plus 1.6 cancels out to 0, and x, anything plus 0 is itself. So x is equal to whatever this is. So because I need to subtract, 6 doesn't come from 2, so we're going to borrow. 12 minus 6 is 6. We're going to bring down our decimal straight down because we lined it up so it already is where it needs to be. And then 7 minus 1 is 6. So we're left with x is equal to 6.6. I want you to go ahead now. I want you to pause this and attempt 8, 10, and 12. Awesome. So by now you should have already paused that and worked through those 3 problems so we can go through them together. So in order to get rid of this addition, what did you do? That's right. You should have subtracted. So x plus 2.5, we're going to subtract 2.5. But what I do to one side, I have to do to both. So 2.5 minus itself is just 0. So this cancels out. We're left with x on that left side, and 7.5 minus 2.5, well, 5 minus 5 is 0. Bring down that decimal straight down, and 7 minus 2 is 5. So x is equal to 5.0. You can drop the 0.0 and say 5. All right, so 10, remember, it's not a fraction, it's division. How do we get rid of division? What's the inverse of division? Multiplication. So to get rid of divide 3, we're going to multiply by 3, so times 3. Times 3. 3 times x is 3x. 1 times 3 is 3. And 3x over 3 is divided by negative 7, or is equal to negative 7 times 3. And we know 3 divided by 3 is 1. So I have 1x is equal to, what is negative 7 times 3? 7 times 3 is 21. A positive and a negative give me a negative 21. Awesome, and we can drop the 1 if we want and just say x is equal to negative 21. Awesome, and this last one, I have what operation there? Right, multiplication. What's my inverse or my opposite of multiplication? Division. Awesome. So to get rid of times for negative 4, we're going to divide both sides by negative 4. Negative 4 divided by negative 4 is 1, so I have 1x. We're going to bring down our equal sign. And then I have negative 2 divided by negative 4. I know a negative divided by a negative is a positive, so I'm going to be left with a positive 2 over 4, or 2 divide 4. And 2 over 4 simplifies to 1/2. So I could say x is equal to 1/2, or I can divide 1 by 2 and say, turn my fraction into a decimal, x is equal to 0.5. Awesome. All right, so I want to do a one-word problem with you, and then I'm going to go ahead and let you do one on your own. So it says if a chocolate cake is still divided into 6 equal slices. So one whole cake divided into 6. That we know that. If we want to be more specific, whole cake divided into 6. That line means division. So how many calories are in the whole? And I know one slice has 280 calories. How many calories are in the whole cake? So I do not know the calories of the whole cake, and I'm going to put CW. Actually, I'm going to put C. Just because if I have 2 variables, it might be confusing. You might think we're looking for 2 numbers. So the whole calories of the cake we do not know. So that's our C. We know that if we divide it by the 6 pieces, we're going to get the total calories of 1 slice. So total calories divided by 6 pieces is going to equal 1 slice. Well, we know that 1 slice is 280 calories. So we can plug that in. So calories of the total cake divided by 6 is going to give me 280. All right, and how do I get rid of division? Multiplication. So I'm going to go ahead and multiply this left side by 6 and this right side by 6. All right, and then I have 6 calories which simplifies to 1 calorie, is equal to 280 times 6. And let's go ahead and figure out what 280 times 6 is. 0 times 6, 0. 6 times 8, 48. 6 times 2 is 12, plus the 4 we carried is 16. So the whole calories of the cake is going to be 1,680 or 1,680. So my solution is that in that whole cake, there are 1,680 calories. Awesome. So I want you to go ahead and pause this now. Pause this and work through this number 14. Make sure you include what you know, what you need to know. Did I put that? We need to know total calories. I should have done that. It's always the question at the end. Figure out what you know, what you need to know, plan it out, work it, and find your solution. I'm going to pause this while you are pausing this so that I can plug in my computer and finish your lesson. All right, so by now, and it's not paused, right? Okay, just double checking. So by now, you should have paused it. Worked it out. Did you pause it? If you didn't pause now. Awesome. All right, so by now, you should have already paused it because we're going to work it out together. It says Pedro made a pot of coffee for some friends. He served 34 ounces to his friends and then measured that there were 20 ounces left over. So he gave coffee to his friends. We know that. How much coffee did he give to his friends? 34 ounces. And then he measured that there were 20 ounces left. So 20 ounces left. So how much coffee did Pedro make? So we want to know how much the total coffee is. So we know that the total that we do not know minus the 34 ounces he gave out is going to give us 20 ounces. So if I get rid of this subtraction, how do I get rid of subtraction? Addition. We're going to add 34 ounces to both sides. So 20 plus 34 is 54. He started out, he brewed 54 ounces. Awesome. So our objective was that we knew our inverse operations. What are our inverse pairs? Say them out loud for me. Awesome. So multiplication and division. Multiplication gets rid of division, and division gets rid of multiplication. What's my other pair? What do I have left? Addition and subtraction. We use addition to get rid of subtraction and subtraction to get rid of addition. And we can use those now to solve one-step equations. And you guys rocked it. We even went this far to do some word problems. We had some fractions. We had some decimals. We had some positives and negatives. We were really, really rocking those one-step equations. Awesome. So that is all I've got for you. Please, if you have questions, bring them to small group. Please, if you feel like you don't get this, come to small group. If you feel like you're rocking it, you can go ahead and do that Schoology homework on this on Schoology. Otherwise, come to our guided practice, get some help, and then do the work on Schoology. All right, that's all I have for you. Have a great day, guys.